Alright, so let's learn about some techniques for actually creating this kind of animation content. Now typically this is a problem for artists, right? Not computer scientists. This is a problem for people who need to make beautiful artwork and creations, and you might be thinking it's not a programmer's problem, but there's a few reasons why we need to learn about it in computer science. One is you kind of need to know how these things work if you're going to be working with people that use them, so it's just good information. Another reason is that some of them are computer science problems under the hood. So they're actually, we'll learn about a few of them that are computer science at the core. And finally, you might find yourself having to connect to or interact with these systems and write code that does that for you, so you need to know how they work. So I'll first start by talking about frame-based animation. We'll go back to where we were earlier in the unit. As a reminder, frame-based animation is where you have a series of raster images like a flip book and you flip through them. Now of course we can always draw these by hand, but that's labor intensive and, as you've seen, quite difficult. So a popular technique to make this easier is called rotoscoping. The magic of rotoscoping is realizing that instead of having to come up with everything ourselves, we can involve real people and real actors, and then what we do, we film them and we just take a picture and we trace the video. So with rotoscoping, we take a film of people doing what we want them to do, and then we trace it. We trace it frame by frame. So trace a real video frame by frame. And the results are strikingly nice looking, and people quite like them. So the word rotoscope comes from a really old-fashioned device. This is a classic device. It's basically a projector, where you have a projector and it goes into a screen that you can trace over, and you can trace one image at a time, and then you get your animation from that. But this has been very commonly used in animation and video games. I'm going to show this video here. If it works, there we go. So this is you see this kid climbing up. He's climbing this thing, and then he's going to be doing a series of actions. Run, 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 jump, right? Jump. So these are all really neat actions that you might imagine a character would do in a video game. So they recorded this. There's sword fighting, and there's even interaction with other people. There's a scene where he hugs another person, a guy hugs her, and then you have this nice video that they've taken of this, and then you rotoscope it, you trace it, and you trace it in a way using your pixel art. So you trace it directly into your pixel art in a way that it comes out looking really natural. So in this particular case, here's the scene we just saw in a game called, this is actually from a game called Prince of Persia. That's the hug scene that they traced from this guy hugging the girl. And so that's rotoscoping. But it actually looks a lot nicer than that. The whole game was done with rotoscoping. So that the scenes you just saw here of the kid running and doing these things, this is how they came up with this animation. So this might look kind of cheesy now, and you can tell by the pixel art how old this is in the colors, but when this first came out, this was really cutting edge. The animation looked amazing, and everybody was like, oh my gosh, how did they do that? Look how amazing this looks. And it was because they actually were tracing real people's actions. So this is a game called Prince of Persia. You'll climb up. It's a pretty fun game. Okay. Here's another classic example of rotoscoping, not from the game industry. This is a classic 80s song. It starts here with this animation, but then when it's a scene of a woman in a cafeteria, and you see here that she's reading this comic book, and then the comic book starts interacting with her. The way they did this is rotoscoping. Right here, they actually have a person's hand coming out of the table, and they just trace over it in a stylistic format, and you get this really nice animated effect. And then this is a very popular music video. So that's rotoscoping. It's a great way of moving toward realistic looking things without having to create the content from scratch. You get to involve real artists and real people in the creation of that. Okay. Cool. So that's rotoscoping. And the other thing I want to talk about is you can actually pre-render all of your frames. So imagine you're in a situation where you have some really complicated scenes that you want to render, but your machine you want to render it on is not capable of doing that. So what you do is you pre-render the scene, pre-render the frames on a higher quality machine from, for example, geometry-based system, and then you save them as raster files, and then you can use them in your frame by your flipbook method, okay? Geometry-based approach. And then you can actually save them as raster files. And then you get very nice results without the cost of doing all that rendering. Wrong one. There we go. So here's a classic game that did this. This is a game called Myst that was very popular, I believe 1990, 1991, so quite old. And it was one of the earliest games to come on CD-ROM format, so it had a lot of space, which in those days was premium. Oftentimes people who bought a CD drive, the CD would be bigger than your computer's hard drive, okay? It's just huge. So they had all this space. So they pre-rendered all these scenes in the game, and it looked 3D, it looked really high quality, but it was just a series of pictures. Even the animations, I'm going to skip ahead here. Right, you move that, you click somewhere, it moves around. You can see that that's just frame-based animation of a pre-rendered scene. So you get to have the benefits of a scene with mapping, texture mapping, lighting, and all these expensive rendered things, but it's actually just frame-based animation. Okay, and the whole game has that nice aesthetic, which at the time was way ahead of its time, and they managed that through this pre-rendering approach. As you go along in time, and games become more sophisticated, you start to merge these. This is a game from about maybe 10 years later, called Fandango, and it was a lot of fun. But they mixed these pre-rendered scenes with these live rendered 3D models. Okay, so these are all live rendered 3D models mixed with a pre-rendered scene. And sometimes you can see the lighting on the model looks different than the scene, and the aesthetic looks a little different. It's hard to do, but yeah, it was pretty seamless when they did it. Everything looked pretty good, but they did it in a way that would save a lot of computational power. Cool. That's one of these classic adventure games that was a lot of fun to play. Puzzle game. All right. And how do I stop this? Okay, so that's all I'm really going to talk about with frame-based animation. We'll come back, slides 6 to 11. We'll come back and we'll talk about, techniques for geometry-based rendering. Thanks.